Next one. Figure 1 shows a part of an experimental setup to determine the resistivity rho of a material of a given wire with the aid of a meter bridge. Right. The resistance value of resistor box is R. Resistance value of resistor box is R. And the resistance of given wire is S. Right. Again, resistance of given wire is S. The length of the meter bridge wire AB is 100 centimeters. Right. A. A center zero galvanometer has to be connected between point C and D. A center zero galvanometer has to be connected between C and D. Right. අපි එක දන්නවනේ එතෙන් එන circuit එක මොකක්ද කියලා. C and D. To protect the center zero galvanometer in the circuit in figure 2 can be used. Right. ඒකත් අපි දන්නවනේ. Right. Safeguard resistor. Name the type of key K2. Right. We have two main types of keys in our labs. Right. One is tap key. The other one is plug keys. Tap keys are used when we need an instant current or when you need to connect the circuit at a point instantly, right? If you need to connect the circuit for a small period of time, split of time, then tap keys are used, right? If you need to have a constant steady current throughout a period of time, plug keys are used, right? Now here we have to keep this shorted until the experiment is done. No? Then tap keys cannot be used. Tap key use tap කරගෙන ඉන්න ඕනේ. If the tap key is used, you have to tap it. If hands are taken off, it is going to untap. Then plug keys are used. K2 is a plug key. K2 is a plug key. Right, මම class එකෙත් explain කරා. When we are doing meter bridge and potentiometer both. Second one. Select the suitable value for the resistance X from the resistances 1 ohm, 10 ohms, 100 ohms and 1000 ohms. For X, no. X is the safeguard resistor. X is the safeguard resistor. Higher the safeguard resistor, lesser the current it flows through the safeguard resistor. No? Higher the safeguard resistor, higher the value of safeguard resistor, lesser the current flow it flows through the resistor. Lesser current flow means higher protection. Lesser current flow means higher protection. That is how it should be. Then maximum possible resistance is the most suitable one. Then we'll go with 1000 ohms. 1000 ohms. Right? Logic එක මම ඕනනම් කියන්නම්. Logic එක මම කිව්වා මම ලියන්නම් ඕනනම්. Right? That should be 1000 ohms. Should be 1000 ohms. And the logic is, listen, logic is higher the resistance, lesser the current. Right? Lesser current means higher protection. Higher protection. Right? Higher protection. ඕක තමයි logic. Higher protection. Right? Next. Before taking measurements, how do you check whether the circuit is connected properly? Right? We are doing the same thing in potentiometer and meter bridge both. Right? First of all, you have to keep the slider key at A. At A and B are labeled, right? Yeah, at A and B are labeled because they are standard labels. A means positive terminal of meter bridge wire, B is negative terminal of meter bridge wire, right? So first you have to keep the slider key at A and B respectively, and you have to check whether the deflection of center zero galvanometer from one side to the other. Check whether it deflects from one side to the other. If it deflects, you can your connections are correct and you can have a balance point. If not, there can be improper connections, right? Then you don't get a balance point. And before taking measurements, how do you check whether the circuit is connected properly? By keeping slider key, right? Concise answers. Concise means you have to answer to the point. Short and sweet answers to the point. Always answer to what is asked, right? What is questioned. Don't go around the question, right? Don't wander around the question. Don't go around the question, right? Answer to the point. Concise answers are expected, right? By keeping slider key at A and B respectively. At A and B respectively. And checking whether center 0 kilometer we can G G deflects from one side to the other, deflects from one side to the other, passing 0, deflects from one side to the other, passing 0, deflects from one side to the other, passing 0. 1 second. One side to the other, passing 0. One side to the other, passing 0. Right? That's a complete answer. Right? Memorize theories, recall theories, right? අපි theory වලදී මේ ඔක්කොම discuss කරලා තියෙන්නේ. ඒ ටික මතක් කරගෙන හරියට මෙතන ලියන්නයි තියෙන්නේ. Right? So you have to answer to the point. Give me 1 second. Right? Take it down. Give me 1 second. Right. Next one. See, when the resistance value of resistor box is R, balance length of the meter bridge wire is L in centimeters, L in centimeters, write down an expression for ROS in terms of L. Neglect the n corrections of the meter bridge wire. Right. See, now the meter bridge is given as R to L, S to 100 minus L. No, then the ratio is R over L equals S over 100 minus L. R over L equals, right, S over 100 minus L. We need ROS. Then subject ROS. ROS is given by L over 100 minus L. L over 100 minus L. ROS is given by L over 100 minus L. Right? Next. For R equals 9 ohms, 26 ohms, and 56 ohms, the balance lengths are 27 centimeters, 52 centimeters, and 70 centimeters, respectively, at 30 degrees Celsius. What is the most appropriate value for resistance R that must be used in order to determine the value of S accurately? Give the reason. Right. Now, the logic here is you have to check this with the balance length. You have to check this with the balance length. You have to check this with the balance length. Right? Balance lengths are like 27, 52, and 70. No? Right? Always when balance length is closer to the middle point. Right? Closer to the middle point. Closer to the middle point. Percentage error we make in both sides are minimum. Right? Then closer to the middle point, percentage errors are minimum. So therefore, always we will be choosing the middle point, closer to middle point. We prefer more closer to middle point to minimize percentage errors, right? If the balance point is biased in one direction, biased to one direction, right, to the lower side or higher side, then percentage errors are higher, right? So therefore, 52 for 52 according the respective one is 26, no? Then we'll be going with 26. Value is 26 ohms. Value is 26 ohms. Reason is about percentage error. You have to explain it, right? Percentage error එක පැත්තෙන් මේක explain කරන්න ඕනේ. You have to explain it using percentage error, right? Minimum percentage error occurs when minimum percentage error occurs when balanced point is close to middle point, close to middle point, right? करना है. So always we prefer to have the balance point in the middle when doing the experiments, right? That's a practice we have to minimize percentage errors, right? Potentiometer ගෙත්තේමයි මේ ගෙත්තේමයි අර එකපාරම මතක තියාගන්න because potentiometer and meter bridge are very two comparative instruments, no, right? Two comparative instruments. In potentiometer also that is same. In potentiometer also that is same, right? To calculate the most accurate value of S using the relevant balance length and R, right? Then we know R of S equals L over 100 minus L, no? Then R of S equals L over 100 minus L, right? Now calculate the most accurate value of S. Now R is 26. R is 26. 26 of S equals L. Now L is 52, right? L is 52. Balance length is 52. Then this is 52 over 100 minus 52, right? Then 26 over S equals 52 over 100 minus 52 කියලා කියන්නේ 48 නේ, 48. See, this is cancelable. 26 times 2 නේ මේ තියෙන්නේ 2, right? So මේ තියෙන්නේ 2 කියන්නේ 24, which means S equals 24 ohms. S equals 24 ohms, right? It's a normal calculation. 24 ohms, right? Right, take it down. Next, E. The values of diameter measured in 4 different places in the given wire are 0.39 millimeters, 0.40 millimeters, 0.40 and 0.41. And the length of wire is 48 centimeters. Length of wire is 48 centimeters. Calculate the resistivity of material of the wire. Take phi equals 3. Right. Then for diameter, we need the average. Right? Average for the diameter, we need the average. No? Then average value of diameter. Average diameter is 0.39 plus 0.4 plus 0.4 plus 0.41 over 4, right? 0.39 0.41 means again that 0.4, no, again make answer again 0.4 0.40 millimeters. Now the average is 0.40. Average diameter average diameter is known, right? It is found. Then and the length of wire is 48 centimeters, right? Calculate the resistivity. Calculate the resistivity. Resistivity කියලා කියන්නේ R equals rho L over N, right? අපි equation එකට යන්න. And the other thing I think I didn't remind you at the beginning, this Sunday we'll be having the thermal experiment seminar, right? Where all the experiments in thermal will be discussed, right? So it will be happening this Sunday. It will be happening this Sunday, 7th, right? It will be happening on 7th Sunday, right? Thermal experiment seminar or thermal practical seminar. Thermal practical seminar. Thermal practical seminar, right? 7th Sunday at 7 p.m. Right? 7th Sunday at 7 p.m. Physically, I'll be at Lisa Corona, and YouTube live will be given for all other students. Right? Keep the date saved 7th Sunday at 7 p.m. Right? Thermal practical seminar. Right. Then you know our equation is R equals rho L over A, right? R equals rho L over A. then rho is given by RA over L. Rho is given by RA over L. හරිනේ. මේක ප්ලග් කරගත්තා නම් හරි. Rho is given by RA over L. Right? Then rho equals R. R was determined as 24. Right? A pi r squared, pi is 3, right? Pi is 3, and radius, diameter is 0.4. Then the radius is 0.2 millimeters. Then it should be 0.2 10 to the power minus 3 squared. Pi r squared, darne? Pi r squared. Then over length was given 48 centimeters, 48 centi 10 to the power minus 2. Right? Have to simplify this. This cancels 24 and 48. 24 times 2, right? Then simplify the rest. 3 times. This can be written as 0.2 times minus 10 to the minus 3 means 2 times 10 to the minus 4. Then 2 times can make a 4. 10 to the minus 4 can minus 8. Over this is 2 times 10 to the minus 2. 2 times 10 to the minus 2. Right? Then 2 to 4 cancels 2. Then rho is 6 times 10 to the power minus 6. 6 times 10 to the power minus 6. Resistivity is in ohm meters. Right? 6 times 10 to the power minus 6. 6 times 10 to the power minus 6. That is in ohm meters. Right? Take it down. Right. Next, take it down. Finished. F. When the above wire is kept at constant temperature of 100 degrees Celsius in an oil bath for R equals 20 ohms, the resistance box. R equals 20 ohms in the resistance box. The balance length is 40 centimeters. Right. Calculate the temperature coefficient of resistance of the material of the wire. Right. Now, first thing, resistance of wire is not given. Right. We have to find it. Then again, we can use this equation we have proved. ROS equals LO 100 minus LO. Now R is 20. Over, I need to find S. Right? ROS. LO 100 minus L. L is 40 now. Then 40 over 100 minus 40. 60. Right? Then 20 over S equals 40 over 60. Right? Which means, simplify this. S equals, cancel, right? 20 times 2, then 30. Again, S equals 30. S equals 30 ohms. S equals 30 ohms. Right? If that is known, we know R theta equals R naught 1 plus alpha theta. Then use this equation. R theta equals R naught 1 plus alpha theta. Right? Now we know two different temperatures. Initially it was at what was the temperature? 30, right? Initially it was at 30. Initially it was at 30, right? It was given somewhere. Where was it? Here, right? It is at 30. Initially it is at 30. Right? Initially it is at 30. Right? එතකොට අර අපි කලින් use කරව අපි හොයාගත්තු 24 කියන value එක ආවේ 30 වලදී. It was at 30. 24 කියලා value එකක් අපි මෙතන calculate කරගත්තානේ. කො මේදී 24. 24 is at 30. Right? එහෙනම් මගේ එක point එකක් ඒක. Then R theta is 24 at 30. equals R naught 1 plus alpha, present temperature 30. And second scenario is here. Now there is 30 ohms, R naught 1 plus alpha, temperature is 100. Divide these two. Divide these two. Right? Then we need alpha. A small simplification to find alpha. Right? Then 24 over 30 again by 6 is cancelled, 6 times 4 and 5. R naught cancels. Right? Then simplify. 4 over 5 equals 1 plus 30 alpha over 1 plus 100 alpha. 1 plus 30 alpha over 1 plus 100 alpha. Right? Then plus multiply 4 plus 400 alpha equals 5 plus 5 times 3 again 150 alpha. Then 5 minus 4 is 1. 5 minus 4 is 1. 400 minus 150 is 250. Then 250 alpha equals 1. 250 alpha equals 1. මේකත් simplify වෙන්න දීලා තියෙනවා. Right? නිකම්ම simplify වෙනවා. Alpha equals 1 over 250. Then 1 over 250 means 1000 over 250 is 4. 1000 over 250. Then 1 over 250 is 4 times 10 to the minus 3. 4 times 10 to the minus 3. Alpha is in per degrees Celsius. Right? Another small calculation. Right? Write it down. බලන්න මේකේ flow එක එතකොට resistance එක වෙනස් කරා resistance එක නෙමෙයි box එකේ resistance box එකේ වෙනස් කරා at 100 degrees Celsius. Then using our same equation, first we can find the respective resistance of wire S at 100, right? That was 30. Then we have two different scenarios, two different temperatures to apply our equation. R theta equals R naught 1 plus alpha theta, right? G. For a certain type of material, the temperature coefficient of resistance is negative around room temperature. Name the type of material. That's straightforward, right? That's a theory actually. That's a theory part that is coming from a theory part, right? Temperature coefficient is negative in semiconductor material, right? In semiconductor materials. That's why we write this equation for semiconductors. We apply this equation for semiconductors as R theta equals R naught 1 minus alpha theta, right? මෙහෙම ලියන්නේ semiconductors වලට. Right? The actual reason is මේකේ reasons explain කරනවා reason එක මේක. අපි variations හදලා තියෙනවා theory class එකේ. R and rho changes with temperature. Of a semiconductor, it decreases. Of a semiconductor, it decreases. When temperature increases, R and rho decreases. Right? That's why alpha is negative. Then there is semiconductors. Material is semiconductor material. Semiconductor material. Semiconductor material. Semiconductor material. Right. That's it. So